All right, you are welcome again. Today, let's take a look at Fourier Transform. Okay, now under Fourier Transform, let's consider this question. We are asked to find the Fourier Transform of the function f of x is equal to exponential minus a absolute value of x, given that x is greater than minus infinity less than infinity. Okay, now let's go. Solution. Taking a look at this, we are asked to transform this function using Fourier transform operator. How are we going to do it? Now, by definition of Fourier transform, the Fourier transform of the function f of x is going to give us the Fourier of omega equal to 1 all over square root of 2 pi, the integral from negative infinity to positive infinity, f of x e raised to the power of minus I omega x dx. Okay, so this is by definition what we mean by the Fourier transform. All right, good. Now let's go. In this case, we are given a function. Now, in place of f of x, we are going to write our function. So that means we are going to say that the Fourier transform of omega is equal to 1 all over square root of 2 pi, the integral from negative infinity to positive infinity, e raised to the power of minus a, the absolute value of x, then multiply by e raised to the power of minus I omega x dx. All right, good. Now let's look at this and see what we are going to do. So in the first instance, what I want you to pay attention to is this absolute value of x. So what is this talking about? So the absolute value of x is telling us that x can assume two values. It could be negative and it could be positive. For instance, when you say the absolute value of minus 5 is equal to what? 5. And then the absolute value of 5 itself is also the same as what? 5. So when we say the absolute value of x, so this x could be negative and this x could be positive. And then from our interval or the limit we are given in this integral, we are given that x is greater than negative infinity but less than infinity. Okay, so now look at this number line. We have from negative infinity to positive infinity, and then at the center we have 0. So telling us now that the absolute value of x can assume two values, right? So we are saying that from this negative infinity to 0, you are going to find negative x. And from this 0 to positive infinity, you are going to find positive number. All right, good. So that means we are going to find the Fourier transform of this function when x is negative, and the Fourier transform of the same function when x is positive. Then we add it together, because the interval we are given is from negative infinity to positive infinity. All right, so that means we are going to find the Fourier transform from the negative infinity to 0. That is when x is negative. And then again from 0 to infinity, that is when x is positive. Now let's go. The Fourier transform of omega, we say, is equal to 1 all over square root of 2 pi. So the first part now, which is the integral from negative infinity to 0. And then when we say from negative infinity to 0, what are we talking about? We are talking about the value of x when it is negative. All right, good. Or the function of x when it is negative. So we have e raised to the power of minus a. So in place of x now, we have what? Negative x. Then multiply by e raised to the power of minus I omega x dx. This is the first part. Then plus, again, the next one, 1 all over square root of 2 pi, the integral from 0 to infinity, e raised to the power of minus a in this side now, that is when x is positive. Now we have x multiplied by e raised to the power of minus I omega x dx. All right? Yes. Now let's combine these two together. This e raised to the power of minus a multiplied by minus x, and then e raised to the power of minus I omega x. So combining these together, applying the law of indices. Okay? So here we are going to have 1 all over square root of 2 pi, the integral from negative infinity to 0, e raised to the power of ax minus I omega x dx, plus 1 all over square root of 2 pi, the integral from 0 to infinity, e raised to the power of minus ax minus I omega x dx. I hope this is clear, right? Yes, we applied the law of indices, and then since they are having the same base, we just add their exponent or their powers. All right, good. Now let's go. In this exponent, we can see that we have ax minus I omega x, right? Let's factor out x because this x is our variable. All right, let's factor it out in both of them. Now that means we are going to have 1 all over square root of 2 pi, the integral from negative infinity to 0, e raised to the power of a minus I omega in bracket x dx, plus 1 all over square root of 2 pi, the integral from 0 to infinity, e raised to the power of minus a plus I omega in bracket x dx. All right? Yes. So from here, we can go ahead and integrate. All right? So integrating, we're going to have 1 all over square root of 2 pi, open bracket now, e raised to the power of a minus I omega in bracket x all over a minus I omega. And then our boundary from negative infinity to 0, plus the next one, we have 1 all over square root of 2 pi, open bracket, e raised to the power of minus a plus I omega, close the bracket, x all over minus, open bracket, a plus I omega. Then close the big bracket, our limit or our boundary from 0 to infinity. All right? Yes. In this case now, what we do here is we factor out the constant or the denominator. We bring it out. Okay? That means we are going to have 1 all over the denominator. Then plug in our upper limit minus the lower limit in both of these integrals. Okay? We plug in, we first of all factor out the constant, which is 1 all over the denominator. All right, so the other thing that is remaining, which is e raised to the power of a minus I omega, okay, x, we plug in the upper limit minus the lower limit. So doing that, we are going to have 1 all over square root of 2 pi, open bracket, 1 all over a minus I omega, open bracket, e raised to the power of a minus I omega, close the bracket. So in place of x now, we plug in our upper limit, which is 0. Then minus e raised to the power of a minus I omega. In place of x, we plug in the lower limit, which is negative infinity, close bracket, plus 1 all over square root of 2 pi, open bracket, 1 all over minus, open bracket, a plus I omega, close bracket. Then open the big one. After when we factor out this constant, what do we have remaining? We have e raised to the power of minus, open bracket, a plus I omega. In place of x now, we plug in the upper limit, which is infinity, minus e raised to the power of minus, open bracket, a plus I omega. In place of x, we plug in the lower limit, which is 0. All right, good. Now, in this place, we plug in the upper limit minus the lower limit in the first side, and then the second one, upper limit minus the lower limit. So in the first side, when we plug in the upper limit, which is 0, so everything there is going to turn to 0. So we have e raised to the power of 0 is going to give us 1. And then the other side is going to give us 0. So going to the second part of it now, when it is the upper bound is going to give us 0, then the lower bound is going to give us minus 1. So here we have 1 all over square root of 2 pi, open bracket 1 all over a minus I omega, open bracket 1 minus 0. Then plus 1 all over square root of 2 pi, open bracket 1 all over minus, open bracket a plus I omega, close bracket, open another bracket, 0 minus 1. Okay, I hope this is clear, right? Good. Now, in this first side, when you use this 1, when we say 1 minus 0 is 1, right? Then multiply this, is still the same thing. So the second side, we have 0 minus 1, which is what? Minus 1. So minus 1 multiplied by this constant. So it's going to remove the negative, right? Good. So here we have 1 all over square root of 2 pi, open bracket, 1 all over a minus I omega plus 1 all over a plus I omega. Okay, so in this case now, what do? We factor out 1 all over square root of 2 pi because we see that it appears in both sides. All right, so as we factor it out, so what we have in this big bracket, we combine it together. So when you add it together, we are going to have 1 all over square root of 2 pi, open bracket, 2a all over a squared plus omega squared. All right, yes. So in this case now, let's bring out these 2. Let's factor the 2 out in the numerator, right? Yes. So it's going to meet the constant outside. So we're going to have 2 all over. And then in this denominator, we have square root of 2 pi. You know, it's still the same thing as saying square root of 2 times square root of pi. Then we have in a bracket a all over a squared plus omega squared. All right? Yes. Now, this constant that is outside, right? Yes. Let's rationalize it. Let us rationalize. How do we do that? We are going to multiply this by square root of 2 all over square root of 2. You know, when you say square root of 2 all over square root of 2, what is it? It's 1. So when you multiply by this, it's still the same thing, all right? Yeah, but let's just do it this way. We say 2 all over square root of 2 times square root of x multiplied by square root of 2 all over square root of 2. Then in our bracket, we have a all over a squared plus omega squared. So as we multiply this, what are we going to have in our numerator? In this value outside the bracket, we are going to have 2 square root of 2 all over. In the denominator, when you say square root of 2 times square root of 2, is going to give you 2. All right? So here in the denominator, we have 2 square root of pi. And then in our bracket, we have a all over a squared plus omega squared. Now, look at it very well. You see that in the numerator, we have 2. In the denominator, we also have 2. So the 2 will cancel each other. All right? So what do we have remaining? We have the square root of 2 all over square root of pi, open bracket, a all over a squared plus omega squared. All right? Yes. You know, in the numerator, we have square root of 2. In the denominator, we also have square root of 2. All right? So we can take the square root of both of them. So we're going to say the square root of 2 all over pi. All right? Yes. Multiply by a all over a squared plus omega squared. All right? Yes. So therefore, the Fourier transform of the function f of x equal to e raised to the power of minus a, the absolute value of x, is giving us the square root of 2 all over pi, open bracket, a all over a squared plus omega squared. Yes, this is the Fourier transform that we are asked to perform. All right? Yes. Thank you very much for watching our videos. Please, if you are new to our YouTube channel, do well to subscribe, like, and share our videos. Stay blessed. Let's take more examples. All right? Yes.